The universe had a beginning, but does it also have an end? One day, the last stars may stop shining, black holes may slowly disappear, and the universe could become colder and darker than we can imagine. So what happens when there is almost nothing left? And what will the final moments of the universe actually look like? The universe is about 13.8 billion years old. That sounds ancient, but compared with what may lie ahead, we are living incredibly close to the beginning. Today, stars are still being born inside enormous clouds of gas. Galaxies still shine with billions of suns, and new planetary systems continue to form. But this cannot continue forever. Every new star consumes part of the universe's limited supply of usable gas. Over unimaginable periods of time, that fuel will become harder to find. The bright age of stars is temporary, and eventually, the universe will begin running out of material for making new ones. Stars cannot form without cold gas, but as generations of stars are born, that supply gradually changes. Some gas becomes locked inside long-lived stars and stellar remnants. Some is heated or expelled by supernovae and energetic galactic activity. Meanwhile, the expansion of the universe increasingly separates distant regions from one another. Star formation has already declined dramatically from its cosmic peak billions of years ago. Far into the future, fewer and fewer new stars will ignite. Galaxies that once blazed with blue young stars will slowly become dominated by older, dimmer populations. The universe will still exist. It will simply become much quieter. Eventually, the longest-lived stars will dominate the sky. Red dwarfs are small, cool, and extremely efficient. Unlike massive stars that may survive only millions of years, some red dwarfs could shine for trillions of years. Long after stars like our Sun are gone, these tiny stars may provide some of the final natural starlight in the universe. But even they have limited fuel. One by one, the last red dwarfs will exhaust their hydrogen. Their light will disappear. And for the first time since the earliest cosmic ages, the universe could exist without ordinary shining stars. When the final stars fade, the universe will enter an era unlike anything we know today. There may be no glowing stars, no bright nebulae, no familiar galaxies lighting the darkness. Instead, space will contain the remains of the stellar age: white dwarfs, neutron stars, cold planetary bodies, and black holes. Gravity will continue reshaping these remnants over enormous periods of time. Occasional collisions may briefly produce energy, but the brilliant universe we see today will be gone. The age of stars will have ended, and an era dominated by darkness will begin. When ordinary stars are gone, the universe won't be completely empty. Their remains will still exist. Stars like the Sun leave behind white dwarfs. More massive stars can become neutron stars, and the most extreme stellar deaths can create black holes. Planets and other cold objects may also continue drifting through space, but without nearby stars, they would receive almost no light or heat. The universe would become a vast collection of dark remnants, separated by enormous distances. The age of brilliant starlight would be over, but the story of the universe would continue. Even these stellar remnants would continue changing. White dwarfs no longer generate energy through normal fusion. Instead, they slowly release the heat left from their former lives. Given enough time, they would become colder and darker. In theory, they could eventually become black dwarfs, objects that emit almost no detectable light. But the universe isn't old enough for even one black dwarf to exist today. Creating them could require timescales vastly longer than the current age of the cosmos. Neutron stars would also cool. The universe would become darker still. Eventually, Black holes could become some of the most important objects remaining. Stellar mass black holes would drift through dark galaxies. Far larger supermassive black holes could remain where galactic centers once existed, over enormous periods of time. Gravitational encounters may eject stars, remnants, and even black holes from their galaxies. As the universe continues expanding, these objects become increasingly isolated. Imagine a cosmos where enormous black holes are separated by distances so great that almost nothing connects them. For an extraordinary length of time, the universe could belong to black holes, but not forever. For a long time, physicists believed black holes could last forever. Then Stephen Hawking showed something remarkable. Quantum effects near a black hole allow it to slowly lose energy. This process is known as Hawking radiation. For the black holes we know today, the effect is extraordinarily weak. A stellar black hole could survive for roughly 10 years. The largest supermassive black holes could persist far longer, perhaps around 10^1 years or more. But given enough time, even they would evaporate, and when the final black holes disappear, the universe would enter an even stranger age. The black hole era would last for an almost unimaginable amount of time. Long after stars disappeared, black holes could remain, but Hawking radiation would slowly reduce their mass. As a black hole became smaller, its evaporation would accelerate. Eventually, even the most massive black holes would disappear. The exact details depend on physics we are still trying to understand. But if Hawking's prediction is correct, there may come a time when the universe contains no black holes at all. The objects that once represented the darkest places in the cosmos would themselves become part of the past. And then, the final black hole disappears. There would be no galaxies shining in the distance, no stars, no planets warmed by sunlight. What remains could include extremely low-energy photons, neutrinos, and other particles spread across an ever-expanding universe. Matter itself may not even survive forever. Some theories predict that protons could eventually decay, although this has never been observed. Whatever remains would become increasingly dilute. Space would continue expanding, while useful energy became harder and harder to find. This leads to one of the leading possibilities for the ultimate fate of the cosmos: heat death. The name sounds violent, but it would be exactly the opposite. The universe would approach a state where energy is spread so evenly that almost none remains available to perform useful work. No new stars, no major sources of heat, no complex structures powered by large energy differences. The universe wouldn't necessarily reach a dramatic final moment. Instead, change itself would become increasingly rare. A cosmos once filled with stars and galaxies would approach a cold, dark equilibrium. So, does the universe actually end? Perhaps not in the way we normally imagine an ending. If cosmic expansion continues indefinitely, time itself may continue. There may simply be fewer and fewer events left to mark its passage. No final explosion, no last sunset, perhaps not even a meaningful final second. Just an increasingly cold and empty cosmos, stretching into a future almost impossible to describe. But this is not a certainty. Our understanding of dark energy, quantum physics, and the distant future remains incomplete. For now, the universe's final chapter is still unwritten, and perhaps that is the greatest mystery of all.